I hope you guys watched the part 1. If not, click the I button or the link to watch the part 1 first. In the previous part, I completely assembled the spy robot. So now in part 2, let's test its working. But before testing, we first need to upload a test code, and for this I am using an ESP32 DevKit board. To upload the code, I connect the ESP32 with my laptop. Before going to the code, this video is sponsored by JLCMC. I will tell you more about them later. After connecting the ESP32, the first step is to select the correct port and COM port in Arduino IDE. Here I have written a simple test code. You only need to change the Wi-Fi SSID and password according to your network. You will find this code link in the video description, and then simply upload the code. Once the code is uploaded, simply press the reset button on ESP32 to get the IP address. Now I copy this IP address and paste it into any browser, and using this web interface we can control the robot wirelessly. Here I've added all the functions like forward, backward, left, right and stop button along with a status bar. Now let's test the code and see the working of our spy bot. This video is sponsored by JLCMC, your one-stop solution for all mechanical parts and custom aluminum enclosure. They provide industry-grade high quality at affordable price. And the best part, their custom aluminum enclosure start at just $1. They also offer shaft coupling, timing belts and timing belts pulleys. In the timing belt category, you will find a large variety of belts including timing belt clamp plates with proper specification. Also, there is an extensive range of belt pulleys available covering all type of pulleys. Furthermore, CAD files are also provided for each and every product, which you can view and download directly from their website. Coming back to our spy bot, when I turn on the power switch, the voltmeter starts showing the battery voltage, so we can monitor the real-time battery level. The 3 LEDs start blinking, which means our spy bot is trying to connect to Wi-Fi. Once the blinking becomes stable, it means our robot is successfully connected, and in the front section, 4 LEDs are also turned on. These LEDs will help in camera visibility, especially in low light condition. As you can see, I have opened the control server on my phone and it's working perfectly. All the movements are smooth and the response is very fast. Now I have uploaded the code in our ESP32 cam, and as you can see, it's working perfectly. The video feed quality is decent. For better quality, we need to use a different camera module. And I took the spy bot outside to check its real world performance. And as you can see, our spy bot is working perfectly. The movements are very smooth, and I tested it on different browse surface and it's handled them really well. Since I test the spy bot at night, the video quality isn't that great, but we can improve this by upgrading the camera module. Also, instead of N20 motors, we can use 12-volt gear motors for better torque and performance. I've already designed this upgrade and you will see it in my upcoming videos. Now, I would love to hear your thoughts. What upgrades or features should I add next? Share your ideas in the comments. And yes, don't forget to check out JLCMC, link in the video description. The ordering is super simple. Select the required quantity, add them into cart and proceed to checkout. You will get your product within 1 week.